Welcome to True Projects. In this video, we are going to explain about the project that is the deployment and the implementation of cloud platform for remote automatic correction of artificial intelligence models. So before getting into the execution, first let us understand what is this project about. Industries today, they are looking to use artificial intelligence, that is AI, to make their production process faster, more efficient, and capable of producing higher quality products. AI can help automate tasks, predict machine failures, and optimize production, which can save time and also reduce the cost. This is particularly important in competitive sectors like semiconductors, where efficiency and precision is critical. However, traditional factories, they still face, that is, they still rely on manual labor and technical expertise, which makes it difficult to implement AI in a practical way. Even though researchers have made significant progress in AI technologies, many companies struggle to apply these solutions effectively on a large scale. This limitation slows down their ability to keep up with the technological advancements and fully benefit from AI in their operations. And here, the main challenge is manufacturing industries face when trying to use AI is first setting up AI systems is often complicated and takes a lot of time. Once an AI model is in place, it can be hard to make changes or improvements. On top of that, developing and maintaining these models can be expensive, which adds a financial burden to companies. And the other concern is the data security. Sending sensitive production data to AI systems, especially cloud based ones, can be risky. At the same time, customers today want customized, high quality products, which means factories need more flexibility in their production process. All of these challenges makes it hard for companies to move from traditional automated production to fully intelligent manufacturing, which can limit their efficiency, productivity, and ability to compete globally. So, to overcome with all such issues, the system design is to help manufacturing industries predict problems automatically, and normally companies would need mechanics or AI experts to check machines and develop prediction models, which can be time consuming and expensive. So, this project uses a watchdog module that continuously monitors incoming machine data. So, if new data appears or the AI model performance drops, Watchdog automatically retains the model and updates it for all cloud users. This allows the system to improve on its own without requiring constant human intervention. So, the system has several key features that makes it easy for manufacturing industries to use AI for predicting machine learning problems, that is machine problems. So the AI model fixes itself automatically and it is deployed to the platform. Users just need to provide machine test data and the model does the rest things. So it is remote dynamic model adjustment. Then comes automated continuous integration. So the Watchdog module constantly updates the AI model with the new data, ensuring the cloud platform always has the latest version. And then automated continuous deployment. So once updated, the models are automatically sent out and deployed to all users without any manual work. Then comes administrator web interface. So users can log in through a web interface to upload test data and see the model predictions. Then comes data security protection mechanism. So the all the test data and AI models are stored encrypted in this project, keeping sensitive information safe and secure. And here, the system uses data from CNC machines to train and test the AI model with XGBoost, checking how well it performs using metrics like accuracy, precision, recall, and FN score, and also confusion matrix. So the project is built around two main modules, that is Watchdog. So this module keeps an eye on incoming data sets, train the model. When new data is available, retains if that is it retains if performance drops and updates the model weights in the server for all the users. So your cloud is nothing but our local server. And coming to web interface, industry users can register, log in, evaluate the AI model, see how long training and retraining take, and upload sensor test data to predict the condition. So this setup, it makes it easy for companies to monitor machine health and improve the production efficiency without needing in-house AI experts. So moving on to further improve the performance of this project, here we have used feature selection using chi-square algorithm. So this method picks out the most important pieces of the data from the data set, removing unnecessary or less useful information. This helps the model to learn better and make it more efficient. Then comes hybrid algorithm training. So after selecting the important features from the model is retrain using a combination of random forest and XGBoost. So by combining the strengths of both the algorithms, the model performs better and gives more accurate predictions. So moving on to flow of work. So these are the modules which are incorporated in this project. First comes data preparation. So at this stage, we copy the data set, that is CNC data.csv, from the dataset folder to the watch data folder. And the dataset contains machine sensor data with the labels indicating whether the tool passed inspection or not. Then comes Watchdog module execution. At this stage, we will be running the Watchdog file to start the Watchdog module. Watchdog monitors the watch data folder for new datasets. When the dataset is detected, Watchdog trains the XGBoost model on the dataset, and if the model performance degrades with the new data, Watchdog automatically retrains the model until the performance improves. And updates the model weights are saved to the cloud, that is the server for all the platform users. Then comes web server launch. So here we will be running a web server which is created by using Flask framework, where users will be able to log in. They will be able to evaluate the models. They will be able to train it, and they will be able to predict the machine condition. So this process, it will continue. Moving on to the requirements to implement this project, basically we need hardware and software requirements. In hardware, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Software requirements are application of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 5. So this is the overview of the project. Now let's execute it. To execute, open the code folder that contains source code file. So let's open the code folder. So these are the source code files. In this, we have the data set that we have trained. So this is the data set that we have used to train the model, that is cnc data.csv file it is. And these are the attributes which are used to train the model. Let's close this and get back. And here we have the model folder in which we have algorithm information that will be loaded into the project code during runtime of the application. And here we have static folder in which we have files related to CSS, JavaScript, and Bootstrap file, which are important for the project's visual appeal. And here we have templates folder. This folder contains all the HTML pages used in this project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And here we have watch.data folder. So in this, we will be copying this CNC data file and we will be pasting it in it, and we will be running the watchdog file to test the watchdog. And here we have app.py file. So this .py file, it contains information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. And this is the database file. This is the watchdog file, and this is the server file to launch the server, and this is the watchdog py file. So now let's execute this project. So to execute this project, first what we need to do is we need to copy this dataset folders cnc data.csv file and get back. And now open this watch data folder and paste it. So here we have pasted the dataset. Now we need to click on run watchdog bat file. So after running this watchdog bat file, it will train XGBoost model on the pasted data set and remove this data set. So let's run this. Click on run. Here you can see watchdog file has been compiled. And here model correction not detected with the accuracy of 99% score. So now let's paste the same data set. If we get back to the application, the pasted file will be removed automatically. Let's paste the file again. Now get back to the watchdog. So here you can see model degradation, that is model degrade detection is detected. So model is retraining with the new and test data. So model degradation is detected. That is why it is training on the new data. And here you have 99% accuracy in it. Let's get back. And now let's run the web server file. So click on run web server.b5 file, click on run bat. And here you can see app file has been compiled. This command will execute Python script and perform a runtime check for any syntax errors or logical issues. And after running this bat file, the application will be hosting the app, that is the server will be hosted at this address. So copy this local link provided by the Flask framework and paste it into any web browser. So I'm copying it and I prefer Google Chrome, so I will paste it in that. So paste the link here, click on enter. And this is the web page of the project, which is displayed in the browser. And this is developed using Flask framework. So we need to get signed up first. So click on sign up and enter all the necessary details to create an account. I have already created, so I'll directly sign in. Click on sign in. Provide your username and the password. Click on login. So we have successfully logged in. Now we can evaluate the model. So click on evaluate model now. And here we have performance metrics. So this is the proposed model, accuracy, precision, recall, and FN score. And here we have algorithms, that is the extension algorithms, 100% of accuracy, 100% of precision, 100% of recall, and 100% of FN score. If you observe, extension model is performing well than the proposed XGBoost model. So now let's train and retrain time. Check the retrain time. So here we have ICI, that is the initial training time, which took 0.1567 seconds, and the retraining time, it took less, that is 0.14 seconds. So first time model training with complete dataset processing time and feature engineering, and this is the continuous deployment retraining with incremental updates and optimization. And here you can see performance comparison. And here you can see a detailed metrics. And these are the training insights. Now let's do prediction. So click on CNC toolware prediction. And here you can see choose file, right? So click on it and select the test data. Click on open. So here you can see dataset has been loaded. Now click on analyze dataset. Here we have the prediction results. So this is the dataset that we have uploaded. And for all the cases that we have given, we have the prediction that it is machine status, whether it is passed inspection or not passed. So for this case, inspection has been not passed, and for this case, it is also not passed. And for these two cases, the inspection has been passed. And for these three cases, I mean, for these two cases, inspection is not passed. And accordingly, for these two, inspection is passed. So in this way, you can evaluate the model. In this way, you can upload some more training data set with the same set of features, and you can predict the model, whether the machine status is passed or not passed. So now click on logout. So with this system, industries can predict machine issues and maintain smooth operations without relying heavily on human intervention. It saves time, reduces cost, and also ensures machine work efficiently, helping businesses stay competitive and productive in a smarter, easier way. This is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.